All right. So let's get the ball rolling. I know it feels good to see all of you in the class. Many of the kids were missing because of summer break, some were on vacation, some were having good time with family in US and in India both. But hard reality school is starting. Yeah?
Mine already started.
Yeah, what is that, bro?
My school already started.
Already started? Already
Yeah,
started early?
sir.
Oh, okay. So Tansi is also here. Hello, Tansi. All right.
Hi, sir.
Hello, beta. So let's start. Let's look at what is that we are trying to cover today. And if I don't know what to cover, then that's a problem. Yeah. Okay. So we'll talk about a fancy word called proportionality. What is constant of proportionality? Give me a quick brief of that, Arab. Yeah, go ahead.
So constant proportionality is like where they make it it goes up in a constant ratio.
Okay, I'll take that and let's hear everybody else. And my request to you all is, if somebody is trying to explain me, keep in mind your teacher is not very intelligent, unfortunately. So explain like you will explain to a child. What do you mean by constant of proportionality? See, this is turning out to be an English class. Constants of proportionality. Okay, let's. Yes, Tansi.
It's when like two quantities, their ratio is like constant.
Getting there. Okay.
So,
Yep. Yes, Ami.
is this for 8th grade or 7th grade?
7th grade.
Okay, definitely.
But again, as I say, any concept that we learn, it has to be as simple and easy to interpret or relate. Now, what do you mean by constant of proportionality? There is something called proportion. Keep like when you say nationality, right? There is a nation in it. So somebody who is belonging to that nation is? Yes or no? So here when you look at proportionality also, use proportion. This is another word. And then you have portion. Now look at this. Yes? Sorry, you were saying something?
That was fast.
Okay, no worries. So now I'm kind of breaking it down for you guys. So Urvi, I met your daddy at Akshay Patra on one weekend, last weekend I think. So he said, my kids come to your classes. I said, yeah. He said, Urvi, and I thought it's Purvi. So Purvi is a girl in 10th grade, in the other class. I said, yes, she's been coming to my classes for last 3-4 months now. No, she's taking only one class. Then I was thinking, okay, I probably am getting old to remember things. But then when I related the names, then I realized, okay, now Tasvik is thinking what is going on here. We're talking about proportionality. Now let me make it easy for you guys. So as I said, proportionality, it has pro and portion. Proportion, right? Something is a portion of something, a part of something. Now look at this. This looks much easier, much lighter. Y equal to 3 times of x. What is y? There is a song, Y is collaborating. Remember that? No? Okay, I'm just kidding. Hello Sandrine, Hazelin. Welcome back, beta. I know you guys had a lot of fun. Okay. So we are talking about constants of proportionality. That's the concept. So I was asking all the kids what is proportionality, and I heard certain things, and I'm just trying to break it down. Proportionality, I'm taking ILTY out, then I'm left with proportion. I'm taking pro also out, I'm left with the portion. What does the portion mean? Portion means a part of something. My hand is a portion of my whole body. It's a part of it. Meaning, if I compare my hand against my whole body, it's one part of it. So, you are actually comparing two things. Here I am comparing my hand against the whole body. Here, if you look at it, if I am looking at this equation, y equal to 3x, if I make, I am comparing y against x. And this 3, I have this thing, right? It's a butterfly. When I move x from this side to this side of equal to, it comes down. It becomes y by x. Yeah. Now, if you look at this, there is a relationship between y and x. Here you are comparing x and y. Yeah. And this relationship says y divided by x is equal to 3, or y is 3 times of x, or x is 1/3 of y. Whichever way you read it. Okay. This is the most fundamental part of proportionality, where you compare two variables or two numbers and you find out what is the relationship between them. What is the proportion? Now you think about baking. Who all loves baking? You love baking? Good that I did not raise my hand, because the day I go for baking, I'll be kicked out of the kitchen in a very royal way. Yes, Gayatri, you also love baking? Okay.
I will take one.
Wonderful, wonderful. That's what I'm saying. So you guys are better off. The day I dare to do so, no dinner for me. Okay. So now let's look at a comparison here. Let's say you are making cake and somebody has told you the recipe. Let's say that super chef is me, who has given you, okay, if you are making cake, make sure for every egg you have 2 cups of flour. So every egg you have 2 cups of flour. 2 eggs, 4 cups of flour. 3 eggs, 6 cups of flour. 1 million eggs, 2 million cups of flour. This is where you are talking about proportion. This is where you are saying, okay, these two are related. If you divide the number of eggs by cups of flour, there is a proportion. If you divide cups of flour by egg, there is a proportion, there is a relationship. Here y by x or x by y. This is representing the proportion of the relationship or the comparison. Here you are saying y comparing with x. Here you are saying x comparing with y. That's how you do it. Yes, Arab.
So the one of proportion are the same as ratio, but different.
Ratio I will not talk about today. It's planned for tomorrow. Now, I mean, jokes apart, but I don't want to overwhelm you guys with too many things in one go, okay? Let's go step by step. But you're not wrong. I'm just trying to hold my horses for 23 hours and 47 minutes. Okay? We'll talk about it tomorrow. And I will let you guys enjoy a break of maybe a minute. I need to rush to get the charger of this laptop, otherwise the class will get over quickly. Laptop runs on a battery less than 3 hours. I'll get a new laptop by tomorrow. Till that time, yeah, I saved the class. All right. So whenever you talk about proportion, you're always talking about comparing two numbers or two variables. And as Arav was saying, it is related to ratio. Be it ratio, be it proportion, these are relatable terms defined in two different ways. So, or even rates for that matter. We'll talk about that in the class tomorrow. Let's look at some relatable problems that will probably make more sense to you guys than me taking you guys through. All the talking that I'm doing. Okay, so now we just briefly touched upon what is proportion, or what is the brief of constant of proportionality. Meaning, as I said, y equal to, let's say, 4x. Here, the relationship between x and y is that y divided by x. Meaning, when I make this x cross the equal to sign, this becomes 4. This is called the constant of proportionality. That is the one that is defining the relationship between x and y. If I say y equal to 1 by 8x, this is my constant of proportionality, which says this is telling you the whole story of proportionality. It says y and x are related in this way. Yeah? And Tashik must be thinking, what is going on? Don't worry about it. When we look at some problems, it will be more related. Yeah? So far it will be okay, right?
Yes, sir. Yes, sir.
Okay. One child is missing, and that is Saira, but she will have to watch the video of the class to be able to catch it. So, proportion, what is proportion that we just looked at? What is the constant of proportionality? Constant of proportionality is nothing but it's the value that depicts the relationship between the variables that you're trying to compare. Now, if you go back to the same problem of making cake, which is a much bigger problem for me. Here, egg to flour. Somebody said 1 egg, 2 cups of flour. Every egg, 2 cups of flour is what you need. So here, egg to flour relationship is 1:2. Every egg, 2 cups of flour. This becomes, you can say, egg to flour. So 1 egg, 2 cups of flour. Okay, let me write it in a neat way. 1 egg equals 2 cup of flour. So 1 cup of flour, if you say, of flour equal to, this 2 will come here, so it will become 1 by 2 n. So you will say, okay, for every egg you need 2 cups of flour, or every cup of flour we need half of the egg. That's the relationship here. So here this, between flour and the egg, it is 1:2. Between egg and the flour is 2. This is your, this term that is getting multiplied here is called constant of proportionality. Now, so far whatever we have talked about, that is all theory. Let's look at the application on that, and then probably you'll be able to appreciate it a little more. Now let's go back to what are the constants of proportionality in all these 4 options that you guys see here. Y equal to 2x, y equal to 3x, y equal to 7x, y equal to 9x. What is the constant of proportionality that you see in this, and this? Yes. You want to see something? Give it a shot. Little louder, better. Okay, that's what I was wondering, who is Lavanya? Yeah, Dikshita, tell me. You are pretty much on money, okay? I'll just describe it. Yes, Dikshita, tell me.
1.
Okay. What? For the first one,
Yeah.
what is the constant of proportionality here?
Oh, I thought you were asking about the proportion side.
Okay. Tansi, the question here is, so we just quickly touched upon what do we mean by constant of proportionality. And constant of proportionality is nothing but the term that represents the relationship between the 2 variables. So Tansi, tell me, for the first, second, third and fourth one, what do you think is the constant of proportionality?
I think it's 2379.
Saurya, are you thinking on the similar lines?
Yeah.
Okay. Sandin Sulain?
I'm also thinking.
Okay. So Urvi, because I remember you as Urvi. So Urvi here, like the way you were saying, these are the constant of proportionality that says x and y are in what proportion. That number defines the proportion between x and y. Meaning, if you have to say y is to x, then you will say, okay, this is my constant of proportionality. In this case, if you get the relationship between x and y, meaning if you bring y and x to the same side, y in comparison to x is equal to 3, and this is your constant of proportionality. If you look at this, in this case y over x, when you bring x to this side, you are left with 7, and that becomes your constant of proportionality. When you look at this, meaning you are trying to see the relationship between x and y, you bring x to this side, bring both of them closer so that you can compare them, and that is when you get a 9. This is your constant of proportionality. Now, some of you who have dealt with coordinate planes before, tell me, what does it mean here? Constant of proportionality, what is the significance of this guy? Yes, Dikshita.
1, 9 or 0, 9.
No, I'm saying, what is the significance of this? That is ratio. What you are saying, one is x to y to x ratio, you are saying it is 9:1 or whatever, right? 1:9, whatever it is. I'm not talking about ratio right now. I'm talking about what is the significance of this one.
Not sure.
Okay, let's see what Tansi says.
Like the constant proportionality tells you how much more it goes every single point. Like from 2, 3 it'll go to.
And what is that called? Slope of the line.
Yeah, slope.
Slope of the line. So now, lot of loaded things coming together and to get you guys confused. Now, let's look at a very simple example and we'll kind of peel off all the layers of the onion to understand this. Now I'm talking about y equal to 2x. Okay? Simple equation. Very amiable, not bothering us. Yeah? As cute as Tasvik. Yeah, I'm just saying. You guys all cute, okay? Not Tasvik alone. So all you all are like babies, right? So yeah. Okay. Some of you will not like it, but yeah, I treat you all like babies. So here coming back to this one. Y equal to 2x. First of all, one thing that I've been talking about so far, this 2 is nothing but my constant of proportionality. Yeah? But this is also an equation, isn't it? It's an equation, right? And if I use this equation, if I say this is an equation, that means there is a relationship between x and y. There is a contract between x and y. What does it say? It says when x is 1, what is the value of y? 2. When x is 2, what is the value of y? 4. When x is 3, 6. When x is 10. Yes, Arihan? 20. So this is an equation. Let's keep aside that constant of proportionality aside, because that is bothering us a little bit, right? It's looking more like a theory coming from an old man. Let's keep it aside. But this is an equation which says the relationship between x and y. For every value of x, there is a corresponding value of y. That's what we saw in the table. Yep? Yeah, Biram. Okay, not a problem. But everybody is with me so far, right? Nihan, you joined a little late, but I'm just hoping that you have been able to follow me so far. Yeah? Now, this equation, I have had a short-term memory loss. I forgot what is constant of proportionality. I forgot. Okay, I forgot. I'm just looking at this as an equation. And when I have an equation, that's a contract of the agreement between the variables. And this is what that contract says. Now, I'm going back to a coordinate plane. 1, 2, 3, 4, 5, 6. 2, 4, 6, 8, 10. Minus 1, minus 2, minus 3. Minus 2. So here I am using 1 unit as a 1 place. Everybody is comfortable with the coordinate planes, right? Okay. So here I am using scale of 1, here I am using scale of 2. That's it. Now, let's try plotting it. When x is 1, y is 2. When x is 2, y is 4. When x is 3, y is 6, 4. When x is 10, okay, I don't have 10, I will replace that with a 4. 4. So this was actually an equation which plot, it was a linear equation again. Linear equation because the maximum power to the variable is 1. So it's a linear equation. It plotted a straight line for us. Yeah? Now, some of you, if you remember the equation for the straight line, last week you would not remember, you would not know this, but don't worry about it. If you compare this with this is the slope-intercept form. Here your value of, in this equation, your value of c is 0. What is this? This is nothing but the slope. Slope of the straight line. So your constant of proportionality is nothing but the slope of the linear equation as well. Is it relatable or it is going tangent? Relatable? So, in summary, this constant of proportionality that you talk about, that is also the slope of the linear equation that we deal with. And this is your line, and what is the slope? You are saying that, okay, my slope is what? For every change of x, how much my y is changing? You change x from 1 to 2. You change x by 1, and how much did your y change? From 4 to 2 to 4. See, that 2. Every change of 1x, you have a corresponding change of 2y. That is the thing here. So that is your slope. So net, a summary of that is, if you are talking about constant of proportionality, if you compare that with the coordinate plane, if you compare that with the linear equation, your constant of proportionality is nothing but the slope of the line that you are talking about. Does it make sense? Shaurya, Sanvita, Sandin, Sulaim, Tansi, everybody? Adri, Karav? Everybody, right? Myra, Gayatri?
Yes, sir. Yes, sir.
Nihan? Sami and Suhina? Everybody with me? Is it making sense? I mean, you don't have to say yes if everybody else is saying yes, okay? I mean, we have the full luxury of going through the concept as many times we want till everybody in the class is clear. So now for task week, okay? Task week, it might be looking little loaded because you are just coming back from a break, okay? So very simple thing, okay? Only a takeaway for all of us. When I have an equal to sign, that is called an equation. Okay? So, and here if you look at this equation, there are three things, 15, 5 and x. 15 is 15. That will remain 15 no matter whether I am 5-year-old or whether I become 75-year-old. 15 will remain 15, okay? That is called, same way 5 will remain 5 regardless of what is the age difference between me and Tasvik. Okay? Or regardless of the age difference between me and even Abhiram. Yeah? That is why they are called constant. They don't change. No matter whatever story you want to tell, they will not change. They are called constant. And this is variable. So when you have an equation with only one variable, you can find out the value of the variable. You are calling it variable because you don't know what it is. You have to find it out. So here you will say, okay, x plus 5 is 15, so x will be how much? 10. See, you can find it out. Now, I am saying x plus 2y equal to 15. Can you tell me the value of x and y? You cannot. You cannot give me one answer for this. If you have two variables, you need at least two equations, okay, to solve it. Let's not worry about that for now. We'll come back to it. But when you have an equation like this, it is nothing but the agreement between x and y. X and y are friends. They have done a handshake, saying, okay, see, my value and 2 times your value added together will become 15. They did a handshake, saying my value, x says, okay, my value is 0. Tell me what is your value? Okay, this is 0, y is 15 by 2, 7.5. When x changes to 1, it will be 15 minus 1, 14 by 2, 7. See, for every value of x, there is a corresponding value of y to meet this agreement. Okay? And when you use this to plot on a coordinate plane, it draws a straight line always. When you have x and y, two variables with no power is in power 1. Maximum power is 1. It always draws a straight line. And when you look at a straight line, there are two ways. There are two ways you can take the straight line. One is called standard form and second one is called y-intercept form or slope-intercept form. Slope-intercept form. That's the better name. So that is what you are looking at. So any equation, any x and y variable equation will draw a straight line for us, okay? No matter what. So you can write the same equation x plus 2y equal to, let's say, 10 in two different ways. One, following this method, x plus by plus c equal to 0. Here, see, a is 1. Here, what is b? 2. And then this 10 will come this side, become minus 10. So c will become minus 10. This is the standard form. And this is just a recap for all of you, okay? Because we are going to deal with this in the coming problems. So this is called standard form of the linear equation. Linear equation because it draws a line. Okay? And second one is called y equal to mx plus c. Where this m is nothing but the slope of the line. How y is changing for every change of x. This is called slope-intercept form, and this c is where it touches the y-axis. When x becomes 0, this is where it touches this line. Okay? So this is just the prelude for the problem that we are going to deal with. I was just helping you guys do a recap of what we know, and some of the things that might be new for you guys, we are just looking at the whole concept all over again. Now let's look at some real problems, okay? So far whatever I was saying was a cooked up story. Now let's look at some real problems, and some of them would be word problems, some could be graph related problems, and we'll see. And who has forgotten about this one? Anybody in the class who has forgotten about this? Nobody? That's a good news. But I see Tasvik is worrying about it right now because he knew about this. I took P out. Urvi is also thinking, what is this going on? So one last time, okay, sorry for you guys. I'll just take 30 seconds. Who wins the race depends on who ran the best. And this is a theory that we have derived for ourselves. R stands for read, A stands for analyze, and N stands for Nike. Nike is a shoe brand whose slogan is just do it. And what does it mean to us? When you have any mathematical problem or any problem to solve, don't jump onto solving it. Go step by step. Read the problem once, twice, thrice, till you are very clear about what the problem is. Then analyze. Think about it. Okay, this problem has given this many information. This is the approach. These are the things that I know. And this is how I will solve. You have made your plan. Then you go to Nike. Then you do it. In short, when you are solving a problem, read it, analyze it, and then you try doing it. Where we go wrong, we jump onto this problem. And even in this class, I know some of you are still not used to this. That's why I'm compelled to talk about it again and again. When you get a problem, read it, analyze it, and then try doing it. You jump onto the last step, solve it. That is where the chances of going wrong is more. Okay? So don't do that. I'm sorry, all the kids who have heard this probably 50th times from me. Okay?
What happened to the key?
Very good. Trust. We are all trusting ourselves. There is no doubt about it. The day I talk about trusting ourselves, we should dismantle this class. If we don't trust ourselves, forget about studying. The day we the day we stop believing in ourselves, there is no point studying. Forget about studies. Okay? That's why that is default. We are not even talking about it. Now let's look at some problems, sample problems, more legitimate problems. I have a graph here. 2, 4, 6. -2, -4, -6. And then 2, 4, 6. I have a line. Okay. The question is, what is the constant of proportionality between y and x in the graph? So this is your x-axis, this is your y-axis. I know my eyesight is weak, but I want to check everybody's eyesight. In this graph, you see 2, 4, 6, 2, 4, 6, this is x-axis, this is y-axis. In this graph, this is the only information given to us. The question is, what is the constant of proportionality between y and x in this graph? Tell me who can give me the answer, and then I will see who can tell me the story also. First, the answer. Can everybody see the board okay? Did everybody hear the question okay?
Sir, I learned from my computer.
Okay.
And it changed the name.
Okay, wonderful. Good. But you heard the question, right, Rita? Okay. And this is the first legitimate problem that we are trying to solve with constant of proportionality. And this is the only graph I have. No other detail. Okay? And I know what problem you guys are dealing with. You have to rely on my drawing skills. No other choice. What is the constant of proportionality between y and x based on this graph? Yes, Arab.
So
Just tell me the answer first. Story I will ask you for later.
so actually, I don't know why.
Gayatri, Sanvita, Saranya, not Saranya.
Is it one?
Hello, sorry. Huh?
Is it one?
I'll take that answer as one for now. I'll come back to you to understand why you think one. Okay? Okay, yes, Tansi.
Sir, could you repeat the question? My internet was lagging.
Okay, so this, unfortunately, there is no question that I can tell you. I have just this graph in the question. Okay? And says, this graph is called, this line is drawn on this graph paper where it is crossing the origin, and I have just put the dotted lines here which says this is probably 3 and this is meeting at 2, and we have been asked to find out the constant of proportionality given this graph. Yep. Let's see who tells me what. Moira, what's cooking up?
Marks?
Uh-huh.
I'm sorry, I could not hear you.
I was asking what is cooking up. What is the constant of proportionality that you can tell me by looking at this graph?
I'm still figuring it out.
Okay, yeah, Tansi.
I think it's 2.
You think it's 2? I got one answer is 1 answer is 2. Okay? You also think 2? Okay. Alright, let's see what Gayatri has to say. Yeah, Gayatri, tell me.
I'm not sure which I can.
Okay. Yeah, Abhiram. Abhiram,
Yeah?
tell me what is going in your mind right now?
I think it's 2.
You also think it's 2?
Yeah.
How about Sami, Suhina, Nihan?
And they didn't get that one.
Okay, how about Sami and Slim? Yes, Myra.
Still doing
I
it.
got 2.
You also got 2. Okay. Yeah, Niham.
Revising it right now, but right now I'm good still.
Okay. Yes, Anand Celine. Kalnuka.
I think it's 2.
You also think to Saria.
Yeah, I got 2.
You also got 2. Then Thanu.
Sir, I got 2, sir.
Okay. How about Sarmita?
So far, I have 2.
Okay. So far. How far? Let's see. Okay. Arihan.
Yeah, I also got 2. Mine got 2.
I'm sorry.
I also got 2.
Okay. Let's see what Arab says.
I got 2.
You also got 2. Yeah, Thanu, you told the answer, right? 2. You can put the hands down. Okay. All right. Now, if I have a line, if I have a graph given to me, and somebody says, find out the constant of proportionality, meaning how is the y value changing for every change of x. Yeah. Now, there was a reason why I had marked this one, so that you guys can see that this line is crossing through the origin and also crossing this point where it is x is 3 and y is 2. Yeah. Now, when I am talking about a straight line in a coordinate plane, constant of proportionality is nothing but the slope of that line. Slope of that line. Meaning, how is, at what rate y is changing for every change of x. Now look at these 2 points. That defines the slope. Okay. Let's see how much y has changed and how much x has changed. My slope here will be how much y has changed. Y has changed from 0 to 2. So my end point is 2, my starting point was 0. Y value. Yeah, please. And how much did my x change? It changed from 0 to 3. So end point was 3. So for 2 change of y, my x changed by 3. 2 unit change of y, my x changed by 3. This is my slope. This is my slope, and hence this is my constant of proportionality as well. Am I making sense or no?
I can't understand this one.
You can't understand it. Now, let me take you guys back in history. Okay? Now, history as in this. If I say, what is the slope of a line? Any line slope. This is less slope, this is more slope, even more slope, even more slope, even, yeah? Slope is increasing. Yeah? When you say slope is increasing, what does it mean?
Like it's getting more steep.
It's getting more steep.
Yeah.
Mathematically, look at this. Here, for one change of x changing by 1 unit, it increases only this much. When you are saying the slope is more, you will see the same 1 unit change of x, y is changing much more. It's rising faster. Right? It's called, what is the term, Arif, Advik, do you remember? It's called run and, what is that? Yeah, go ahead, tell me.
It's called rise.
Rise,
Your body by run.
rise by run. So meaning for every run, how much it is rising. That is what is slope. So here when you are saying slope is less, meaning it's rising less for this much of a run, for 1 unit of run. This slope is more, meaning it's rising more for this much of a run. So x is run, y is rise. Here when you say this slope is more, that means for every small run, there is too much of rise. See? So in this equation also, what I was saying was, this when you are given a line and you have been asked to find out what is the constant of proportionality, you are essentially being asked to find out the slope of the line. Meaning, how much is rise to run ratio? Does it make sense, Suina? Rise to run ratio. So in this equation, see, I have made this so dirty that it's difficult for me to recover. Had it been a computer, I would have done Control Z, things would have been fine. But it's okay. Now, this is my line. This was our line, right? So, when we are given this line, we have been asked to find out the constant of proportionality, and that says what is the slope, meaning rise to run ratio. What is my rise? From here to here, if I look at how much did I rise? I rose from 0 to 2. 2 was my end point and 0 was my starting point for this particular piece. And how much did I run? I ran from 0 to 3. So rise to run ratio is 2:3. Rise to run ratio is nothing but the slope of the line. Or in other terms, you can also say y equal to 2 by 3x, because this is the slope of your line also. Is it making sense now? So all of you who gave me the constant of proportionality answer as 1 or 2 has to be looked at a little differently. Did it make sense to everybody, or it made sense only to me? And you guys can be brave and say, yes sir, it was making sense only to you, so explain it one more time. And that's okay.
It makes sense.
Made sense?
It makes sense.
Okay, okay. So I'll have to remember Deechita with the second last name. That's the best clue I have. If Deechita logs in with the same ID. Okay, no, that's it. So because what happens is, I always there's some new kids joining the class. Okay, so when the new kids join, I would probably get lost, and I will start wondering, is it a new kid or an existing child? And that is where I start messing up with the names. So that's why I'm paying extra attention. But are you guys clear about it? Everybody? So we have just 10 more minutes left for the class. What I will do is, I will put another question, okay? And this needs a bit of practice. See, now ratio, rate, proportion, everybody knows. We use it every day, from morning till we go to sleep. We use it so many times. But then when it comes to applying it, relating it with different concepts, sometimes it gets a little tricky. So that's why it's very important to be able to relate. Now we have another question. Yes, Deekshita.
I need to leave.
Okay. So anyways, whoever has to leave early will have to anyways watch the video. Even if you leave early or not leave early, you have to watch the video of the class to revise. So it's okay with that. Alright? Bye-bye. I have a question. It says, which line has a constant of proportionality between y and x of 5/4? So which line has a constant of proportionality as 5/4? And we are given two options, 2, 4, 6, 8. 2, 4, 6, 8. Second one went from here to So you guys have 3 lines here, okay? And it says which line has the constant of proportionality as 5/4. Now let's see how you guys can make a guess. Gitesh, are you with me or something is bothering you? Are you able to follow me so far?
Yeah, I'm not getting following.
Okay, good. So we have 3 options here and we have been asked to find out which of this has a constant of proportionality is 5/4. Now let's see what Tansi and Advik have to say. Yep,
I think it's the middle one.
middle one. Okay, I'll come back to you with your story. Let's see what Advik has to say. Yeah, Advik, just tell me the answer for now. Middle one. Okay. What's going on? Thinking about it? Let's see what Udvi has to say. Yeah, Sardines Lane, tell me done.
I think it's the middle one. I like both.
Middle one. Okay, Myra,
I think it's the middle one as well.
Saurya.
Steve, I think it's the middle.
Okay. Middle one. Okay. Let's see one more answer and then we'll start. Okay. Karthik, any guess? No guess. No guesswork. Math is not about guesswork. It's about doing it or not doing it. Okay? Alright. Now, let me take one of you to tell me a story. Yes, Arihan.
Yeah, that's the middle one.
Middle one. Now, let me ask Sandra Suri to explain me. One of you, just give me a story, okay? Tell me why you think it's middle one. And again, it is not to question you being right or wrong. I'm just trying to hear your story.
We think it's the middle one because 5/4 is greater than 1. And if you go towards 1, we see that it has the highest. So that's why we chose the middle one.
Okay. So let's see what Myra has to say. Myra has not spoken yet. Myra, tell me your story, beta. Tell me how do you explain that to me? I mean, why you think it's 5/4, the middle one? Any thought that would have gone behind the scene? Myra, that was a question for you. I can't hear you. Myra will deal with this offline. Okay, let's see what Tansi has to explain. Yeah, Tansi.
I thought it was a middle one because I was seeing where the line hits 4, and if it's even close to like 5. And if I look at the one that goes the highest, when it goes to 4, it's way too high to be 5 on the y-axis. But if I look at the lowest one, it's way too low because
Okay.
it's like 4 lines at 2.
Okay. Sanvita, you did not say anything to me, beta. Tell me, what is your thought?
I was a little bit confused on how everyone thought like the middle one.
Okay. Arif?
I think the middle one is if you apply right and left, you can see where the middle one intersects with 5/4 if you actually think about it closely.
Okay. Alright. Ulvi, give me some story. Okay. Okay. So, see, I see you guys are putting your thoughts around it and it's going the right direction. Now, let me break it down mathematically. For me, what is my constant of proportionality? That is nothing but the slope, rise over r. And thanks Arab for helping me recall the term. Okay, I was forgetting that. So rise over r. If you look at this guy, how much? So this is slope is simple. How much x has changed and how much y has changed. Change of y versus change of x. My y has changed probably 3. And how much my x has changed from here to here? It has changed by 8. Much lesser than 5/4. Let me go to this guy and pick up any point. that I can relate. And again, my drawing might not be perfect. I'm just trying to relate, okay? Visually we have to pick up. This one changed by how much? It changed by here. Y changed by how much? Almost like 6 if my drawing skills are okay. By 4. Instead of 5 by 4, 6 by 4. Maybe my drawing went a little bit here and there. Maybe this is correct, but we'll just check this one also. This one is out of question for sure. Let's look at this one. How much is this one? If I look at from here to here itself, if I draw this, I see for here if I look at how much y changed almost by 8 for x of 2. This is much higher than this number. This is 4. This is little more than 1.25 it is. This is, if this calculation is correct, this is 1.5. This is 2. And this is less than 1. This is the closest. Even if you give me the discount for my drawing skills. Yeah? Does it make sense? So, simply put, any line, linear equation, any graph that you look at, your constant of proportionality is nothing but the slope of that line. That tells you the rise and run ratio. Okay? The relationship between rise and run. How much your y is changing for every change of x. That is your slope. And that is how you can relate constant of proportionality or slope of a linear equation as the same thing that you can use interchangeably. And how you will find out, look at how much you pick up any 2 points. You can pick these 2 points also. You will have to find. X has changed 1. Oh, y is only changed by 1. 1 over 1. This is much less. This is more. And this is much more. This one is looking closer to this. So when you have multiple choice question, you will exclude this and you will rule this out. Then you are left to put this out. Yep. We'll do some more problems on this one and then we'll talk about ratio, rates in relation with proportion, and then we'll look at related word problems to make sure that our understanding is right. With that being said, I will let you guys go. Enjoy the rest of the evening. Talk to you guys tomorrow same time.
Bye.
Bye bye. Bye bye. Bye bye. Bye bye.